In this video, let us cover monitoring Snowflake Openflow. We'll be covering telemetry architecture, event table schema, some example queries, and troubleshooting. In telemetry architecture, we'll focus more on Openflow runtime. And in event table schema, it's a standard OTL framework, Open Telemetry framework, that contains log and metric records. In some example queries, we'll query on the event table where all of the logs and metrics inserted. In troubleshooting, let us use some SQL queries to query event table to monitor health and debugging issues. Telemetry architecture and event table. How Openflow logs flow into Snowflake. Default table versus custom event table configuration. Telemetry architecture and event table. How Openflow logs flow into Snowflake. Default table versus custom event table configuration. Let us see the flow of how telemetry works. Initially, the Openflow runtime pod emits OpenTelemetry logs and metrics. Then OpenTelemetry collector collects from kubelet plus runtime processes. And then Snowflake event table gets all of the events, captures all of the events into Snowflake telemetry events table. That's the default table for OpenTelemetry framework. And at the very end, you can use SQL query to fetch the data from events table and send an alert. On the right side, let us see event table setup. You have a default event table under Snowflake, telemetry, and events. But for Openflow, you can also customize your own events table. Let us see step by step. Event table setup. Default event table with no configuration needed. It is snowflake.telemetry.events table. In the option where a dedicated Openflow event table, which is generally recommended for performance plus access control, create an event table called events under openflowdb.telemetry schema. Grant access to the Openflow admin role. In this syntax, use or role account admin. Grant usage on database OpenflowDB to role Openflow admin. Grant usage on schema OpenflowDB.telemetry to role Openflow admin. Point the deployment to custom event table. So you have a deployment. It could be on SPCS or BYOC. You can change that to point the deployment to an event table using alter command. In this case, alter Openflow data plane integration my underscore deployment, which is the deployment name. Set event table equals to whatever the table that you want to point to. In this case, we are pointing events table created under OpenflowDB under schema telemetry. Verify the active event table for your account. We can run show parameters like event table in account. It lists an active event table for that particular account. All Openflow telemetry is tagged with resource attributes application equals to Openflow, and we should always use this filter when we are monitoring or setting up observability on Openflow. A tip here is a dedicated event table for Openflow deployment is strongly recommended. It improves query performance, enables fine-grained access control, and simplifies monitoring. Let us cover event table schema telemetry structure. Every Openflow telemetry row uses these 5 key columns. They are all based on OpenTelemetry standard. One is resource attributes. Second one, record type. Third one, the record itself. Fourth one, record attributes. And fifth one, the value. Let us see what we get from resource attributes. It is the metadata about where the event came from. In this case, application equals to Openflow for Openflow telemetry. And we can also see what is the cloud service provider. We can just give AWS, Azure, GCP, or SPCS. K8 namespace is the runtime ID, and pod name is the runtime key. In your BYOC, you would clearly see the pod name and give that pod name. And K8's container restart count is also an attribute where how many times a pod is being restarted. Openflow data plane ID is the UUID of deployment. Let us see record type. What are the values in record type column? The type of telemetry row. It contains log, metric, and trace. Trace is not used by Openflow, but log typically log messages from runtime, and metric is a numeric measurement. In record column, it will have metric definition for all the metric rows. Let us see some examples here is metric.name. The metric name is connection queued duration max. We will have several metric names that we can use to filter. Metric unit, you want it either in millisecond, byte, or by thread. Metric type is gauge or sum. Value type int or double. Aggregation underscore temporality is either cumulative. It is cumulative for sums. Is monotonic equals to true for cumulative metrics. That's about record column. Let us see what are the attributes that we can fetch from record attributes. The component that produces the metric log. Component, we can use put snowpipe streaming or anything the processor names. Type equals to processor. It can have connection or port. Name equals to human readable component name. ID is the UUID of the component. Group ID equals to parent process UUID. Execution mode either all or node ID. Let us see what is the column value. It's the raw telemetry payload. In this, you will have metric, which is a numeric int or double. You have log, that will have a JSON string with fields, formatted message, level, logger name, timestamp, thread name, use try parse JSON value to parse all the logs. So this is a slide that represents what are the columns within an event table schema, and different attributes are different rows within a particular table with some examples. In this slide, let us go over example queries like flow files and processor status. Example like detect stuck connections and verify processes are running. So how do we do that? We query open telemetry events table in Snowflake database. If it is a customized events table, you replace that Snowflake telemetry events table with the customized table. But in this case, let us see if I want to detect the stuck flow files if they are queued greater than 30 minutes. I would use this query like select star from, and where max queued file minutes is greater than 30, but within that I'll be collecting the data for this particular query with Snowflake telemetry events table, where record type is the metric, record metric name is connection queued duration max, it's an attribute name, and timestamp is greater than the current time minus 30, which is last anything greater than last 30 minutes. And you have a group by on these columns and order by the, the max queued file minutes. So it will only fetch if anything greater than 30 minutes. And you'll also select the data plane ID, deployment, namespace, and the connection name, connection ID, and max queued file minutes. So you have information within this query, and we can use this information to send an alert based on the thresholds defined. Similarly, check processor running status. Let's say if I have a processor that is running or stopped, or if it is failed. So we can fetch that using a select on telemetry events table by providing where clause with metric name as processor run status running. So, and record type equals to metrics, timestamp is greater than the current time minus 30. So in this case, this will either return 1 for running or 0 if it is not running. It could be stopped or failed. So in this way, you will be able to figure out if we are trying to track a processor running status in frequent intervals. Example queries that is fetched from logs and CPU usage. In this first query structured runtime logs. How do you get that? We have to parse the log using try parse JSON function. So if you take a close look at select query from telemetric event tables, where timestamp is provided, record type is log, record attribute is the K8 namespace, which is runtime name. And now you have the log is coming for this particular runtime, and we are parsing that log. Now when you parse that, there are attributes from the parsed log with level, logger name, formatted message, and throwable. This information can be used to query or capture the data in real-time dashboards. Monitor CPU usage, scaling indicator. If you want to monitor the CPU usage threshold, we'll have on the same events table with the record metric name, K8 spot CPU time with record type as the metric. If you closely observe, record type here is a metric. Here the record type is a log. So fetch that metric for the particular pod CPU time for a particular time period. And then once you get all of the details related to data plane ID, namespace, which is the runtime key, and the pod name, the value is what it provides for the CPU usage. And if CPU stays at max across all pods, typically how you want to solve is increase the max nodes for a runtime, increase the concurrent tasks per processor, investigate bottleneck processor. So with this query, you'll be able to identify what is the CPU in nanoseconds, CPU nanoseconds, and fix the runtime accordingly. Key application metrics reference. Most important metrics to watch, like record metric name, values to use in where clauses. Let's say if we can divide that into categories, you have connections, you have processors, you have JVM, and you have system. Or how do you fetch that? Let's say if I want to fetch connection information, you'll see under metric name, connection queued count, connection queued duration max, connection queued bytes. These are some metrics that I can fetch related to connection, and the corresponding unit is given here if it is file or millisecond or byte size, and the type of that particular matrix is gauge, scope is for all, and what it tells us, number of flow files waiting in a connection queue, longest time any single flow file has been queued, that's for key health indicator, and total bytes currently sitting in a connection queue. Let us go over processors. When it comes to processors, you will try to see if your processor is running, what are the tasks that are running on a processor, flow files received, flow files sent, and the bytes received. You have metric is measured by file, task, or byte. This the type is a gauge, and then what it tells is number of tasks the processor executed in the current interval, flow files received by a processor, flow file sent by a processor, bytes ingested by a processor. So several metrics related to processor. Everything that we see here is good for observability. You can leverage these metrics to send alerts or create dashboards. We have JVM and system as one of the categories. You'll also can monitor heap used, threads count, or the pod CPU time, and they can on the type of those metrics are gauge or sum, and to monitor JVM heap size or active JVM thread count or cumulative pod CPU time to detect scaling need. So these are some key application metrics that can be used for setting up observability for Openflow. Troubleshooting guide. Typically, why we set up observability, why we set up some dashboards, we want to identify the alerts and also take the action and resolve the issue. Let us go over some of the troubleshooting guide here. Flow file stuck in queue, which means max queued file minutes is greater than the threshold, which means it could be because the downstream processor cannot keep up with incoming data rate. So what do you do to resolve that? Increase concurrent tasks on put snowpipe streaming processor, increase max nodes on runtime, or reduce max batch size to lower memory pressure. Processor stopped. What it means? If the status of that processor is not running, that means it could be caused by authentication failure, connectivity issue, configuration error, or unhandled exception. How do you resolve that? Check OpenFlow canvas for red indicators. Open bulletin board for error details. Query event table for error, warning, logs filtered by the processor's logger name. High CPU across all pods, data falling behind. The cause could be runtime at max nodes with sustained high CPU processing bottleneck. How do you resolve that? Increase the max nodes for runtime, increase concurrent tasks, investigate bottleneck processor using processor task count metrics. No logs appearing in event table. That means something else is causing not having the logs enabled. Event table not configured or log level not set high enough for capture. The resolution is confirm show parameters shows active event table or not. Set log level to one or error at account or database level. Verify application equals to OpenFlow filter. That would give whether the logs are appearing in the event table. Kinesis, no data produce, no error bulletins. Because if there is an error in AWS KCL library not propagated to OpenFlow UI. How do you resolve? Query an event table, filtering logger name like software, Amazon, Kinesis, and level in Warner error. Check for IAM permission errors on Kinesis register stream consumer. BYOC deployment issue need to escalate to Snowflake support. If the cause is because of complex infrastructure or networking issue requiring Snowflake engineering review, send a support ticket to the Snowflake team. What they do, run diagnostics.sh from EC2 instance connector, instance connect on OpenFlow agent, share pre-signed S3 URL with Snowflake support, valid for 1 hour, and they will debug and resolve the issue. This is some information and examples related to troubleshooting OpenFlow errors. Overall, a quick reference to monitor OpenFlow at a glance. Everything that we need in one place for daily monitoring is common where class filters, like all the open telemetry resource attributes, where application equals to OpenFlow for OpenFlow, and for others for other resources. Specific runtime name, right? Specific deployment name. Typically, always use last 30 minutes. And only metrics are the metric and log. No only errors and warnings from log rows using try parse JSON value where error, level in, error and warning. Some of the key metric names are queue health, processor metrics, and system JVM metrics. And log JSON structure, try parse JSON. That's a function that can be used to parse the log file, and it will produce the attributes like level, logger name, formatted message, timestamp, thread name, and throwable like class name message and step array. Example, filter by specific processor where try parse JSON logger name like a particular OpenFlow runtime processors like put snowpipe streaming, and try parse JSON value level equals to error. So we get some data when querying with filters like this. With this, we have ended how to monitor OpenFlow for observability.